So when we left off in 2.1, we were talking about solving a linear equation. And so now we're going to look at some examples where we're doing this. So let me grab my whiteboard and we'll do it on that. So here are two problems we're going to start with. And we're following those 4 steps that I had on the board earlier. And so the first thing we're going to do is we are going to gather like terms. It says remove grouping symbols and collect like terms. I don't have any grouping symbols, but I do have 2 like terms on the same side of the equal sign. So if you have 2 like terms, what you're going to do is you're going to take the 5 and the 2, you're going to add it together. These are like terms because they share the same variable with the same exponent. And I'm going to say 7x plus 1. So I've gathered the like terms. And now I'm going to move on to step 2, and it says collect all the variables on one side and all the constants on the other. Here I have a variable and a constant term here, so I'm going to move this constant term over. Because it is plus 1, I'm going to choose to do the opposite, which would be subtract 1. And when I subtract 1 from this side of the equation, I'm going to do it to both sides to keep the equation balanced. So that will zero out, and I'll be left with just 7x. And on this side, 50 minus 1 is 49. Now, that is what I wanted to do. I wanted to get the variable terms on this side, the constants on the other, and then I need to now do step 3, which is isolate the variable. I want to get the x by itself. Because this is 7 times x, do the opposite. Divide by 7. But I'm going to divide both sides by 7 because I need to keep the equation balanced. And I end up with 49 divided by 7, which is 7. Then I go and I'm going to check my work. And so I'm going to say check over here. I go back to the original. The original is 5x plus 2x plus 1 is equal to 50. And wherever I have an x, I'm going to put a blank spot. And in place of that blank spot, I'm going to put my proposed solution. My proposed solution is 7. And I'm going to make sure that the left side is equal to the right side. So on the left side here, I have 35 plus 14 plus 1. Because remember, I have to do my order of operations, which means I will multiply each of these before I'm going to add them together. 35 plus 14, that's 49, plus 1 is 50 on this side. So the 2 sides are equal, and so since the 2 sides are equal, I can say that my proposed solution of 7 is correct. Now let's look at the next problem. The next problem says I have 3x minus 7 is equal to 10. I don't have anything to collect on the same sides. Like this side, I can't simplify it. This side, nothing to simplify. So what next step I'm going to move to is number 2, which says to collect the variable terms on one side and the constants on the other. So in step 2, that tells me to subtract, because this is plus 7, I'm going to do the opposite, subtract 7. And I'm going to end up with this. And now isolate, step 3. Isolate by dividing both sides by 3. Do the opposite of what this is 3 times x, it's multiplication. The opposite of that would be division. And I end up with this. Go back to the original and check it. So I'm going to check, and I'm going to put a blank spot in place of the x, and in that place I'll put my proposed solution. 3 times 1 is 3. 3 plus 7, is that equal to 10? And the answer is yes. So since the 2 sides are equal, then I am going to say this proposed solution of x is equal to 1 is a true statement. Now, let's go back to our packet, and if we flip to the next page, we can see that we have this problem. And so what I would suggest here is that you pause and you try this one and then come back to the video and see how we do it together. All right, so now that you've tried it, let's do it together. This is 4x plus 5 is equal to 29. The first thing I need to do is move all my variables on one side, all my constants on the other. So because this is plus 5, I'm going to subtract 5, and I'll do it to both sides. Then this is 4 times x, so I'm going to divide both sides by 4, and I end up with the value of x is equal to 6. The 4 divided by 4 will give you 1x, which I have here. This is my proposed solution. I'm going to check it, and I will check it by saying go back to the original, and I put a blank spot in place of the x, and then plug in your proposed solution of 6. See if the two sides are equal. 4 times 6 is 24, plus 5, does that equal 29? And the answer is yes. The two sides are equal, so then I can say that my proposed solution of 6 is correct. Now, let's try another problem. So I'm going to divide this page, and I'm going to write out my next problem. So, using the same steps that we've been talking about. Here, this is x over 2 minus 7 is equal to negative 3. What I'm going to do here is I'm going to say, here's minus 7. I'm going to do the opposite. I'm going to add 7. And I'm going to end up with x over 2 is equal to 4. Because this is division by 2, I need to do the opposite. The opposite would be to multiply by 2. What I do to one side, I have to do to the other. Here, the 2 will cancel out this denominator, leaving me with 1x, and I get the answer of 8. Now, I've been showing you how to, just put it on your paper and check it by hand. You can also check it using a calculator. So let me bring over my calculator, and let's check it together with the calculator. So, in place of x, I will put in 8. And so with the calculator, you check one side, and then you would check the other side, because sometimes you can have x on both sides. And then just make sure that you get the same answer on both sides. So here, when I put 8 in and divide by 2 and subtract 7, I should get negative 3, and I do. So then I know that this is my answer. Now, this particular problem that I gave you does have a fraction in it. And when you have a fraction in your problem, you can solve it using a different method. The method, we talk about it and at the bottom of this page. So in this one, we have 3 fractions. We have with denominators of 4, 14, and 7. So I want to first show it to you, this method, with this one, because in this one, we have one denominator. And so this method says, get rid of the fractions, or clear the fractions. So clearing the fractions will be the first step. And to do that, you multiply by what's called the least common denominator. Now, we will talk more about what the least common denominator is. But in this case here, you only have one denominator. So with one denominator, then the least common denominator is only possible to be that one. And so I'm going to multiply by the least common denominator, and I have to multiply everything. And when I say everything, I mean every term. So I'm this term, and this term. So I'm going to write out my 2's here so you can see where they go. This will be 2 times x over 2. This will be 2 times 7. And this will be 2 times negative 3. The goal here is to get rid of the fraction. So it should divide out the fraction. If it doesn't, then you've chose the wrong least common denominator to multiply by. This 2 divided by 2 is 1x. Here I get 14, and here I get negative 6. And now I'm going to, now this becomes a problem like we've just seen. Let's gather all the constants on one side, the variables on the other. I end up with negative 6 plus 14 is 8. So I end up with the same answer either way I do it. So now let's look at it with this problem. In this problem, we have 3 denominators. We have to find what's called the LCD, or the least common denominator. And so how am I going to pick out the least common denominator? The least common denominator is going to be the least common multiple of the denominators. That's what it is. And so when I say least common multiple, the word multiple, sorry, spelled that wrong. The least common multiple is going to be multiples of 4, 14, and 7. So one way to do this, and I'll show you another method also, is to take 4, 14, and 7 and write out each of its multiples. So the multiples are like when you're counting by 4s, or 4 times 1, 4 times 2, 4 times 3. It's going to be a number that is larger than, it's either itself or larger than. So these are the multiples of 4. And I could go on forever, right? And the multiples of 14. And then the multiples of 7. And so you need to look through the 3, and you need to decide, sometimes you'll have more than one that they have in common, but you want the least common one, so the smallest number. And when I look at this, I see that all 3 of them have 28 in common as a multiple. So I'm going to choose 28. So the least common denominator will be 28, and we will multiply both sides of the equation by 28, filling in the blanks here. So I'm going to take, and I'm going to multiply this side by 28, and I'm going to multiply this side by 28. So let's put the 28 here first, and I like to do this so that you can see where the 28 is going to go. So I like to write out this step. So I've got the 28 in 3 places. And now I'm going to take and simplify. So the 4 goes into 28 7 times. 14 goes into 28 twice. And 7 goes into 28 4 times. And now distribute this 7 and distribute this negative 4. So I'm going to end up with 7x minus 21 on this side is equal to 10 minus 4x minus 20. And then let's collect our like terms. We have 10 minus 20 here. So I'm going to collect that to be 7x minus 21. Nothing gathers there, but this will be negative 10 minus 4x. Now move over the 4x to obtain 11. X minus 21 is equal to negative 10. And then let's solve this. add 21 to both sides, divide both sides by 11, you end up with x equals 1.